welcome to the today's topic. So today we will go into the problems on Olap operations for the multi-dimensional data cube that at the possible level. What are the possible levels can be, we will see. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. I am going to cover the problems related to the Olap cube and the related operations. What are the different operations are there, that is roll up, drill in, drill down. So that we will take as a introductory part, and then we will take an example, and then we will see the how we are going to drill down, drill up, roll in, and etc. First, we will see the introduction of Olap cubes and different operations in short. So the Olap is nothing but Olap is online analytical processing. That is a computer-based technique to analyze the data to look for some interesting patterns, some of the interesting insights. So Olap stands for Online Analytical Processing Server. There will be server in architecture we have seen. So it is based on the multi-dimensional data. The data will be stored in the data warehouse that will looks like a multi-dimensional data. That will be seen as a form of data cube. So it is based on the multi-dimensional data model, and that is going to allow the user to query on that multi-dimensional data. So if some data related to Delhi, that is related to some year 2018, that is having the sales data. So like that, some of the particular hierarchy will be there in the form of multi-dimensional data. So the Olap database will be divided into one or more cubes, and that cubes will be known as a hypercubes. If more than three cubes are there, more than 3 dimensions are there, that will call as a hypercubes. So less than 3, that will call as a simple data cube. So 3D data cube will be there. So a cube can be considered as a multi-dimensional data generalization of 2 or more 3-dimensional spreadsheets. The Olap cube is a data structure that is optimized for very quick data analysis. So that the Olap is cube is nothing but for the fastest analyzation we have to use the data cube. So the Olap cube looks like that. In the figure we can see that is a 3D Olap cube. So that is having the 3 of the dimensions, the product category, the territory, and that is having the third is quarters. So in there we can see there will have some cells. So that is a combination of cells. So that there will be the 16 cells in the one part. There will in the one plane. So the data Olap cube consists of numeric facts that is called as a measure. So there the fact will be there that will call as a measure, and that will be categorized as a dimension. So there will be the 3 dimension X, Y, Z, that is a product category, territory, and quarters. So that is having the numeric facts, that is in each of the cells having the numeric facts. So each of the cells of the cube holds a number that is going to represent some of the measure of business related to business, that is sales, profit, expenses, budget, and forecast related to prediction. So that will all comes under the one cell. So the cube can store and analyze the multi-dimensional data in a logical and orderly manner. So that we are using as a quickly data analysis for any multi-dimensional data. The Olap cube. So Olap cube is multi-dimensional data cube that is used in the Olap technology are the basis of the data storage and as well as the organization. So in the data warehouse, the data cubes will be stored in the form of multi-dimensional Olap cubes. Small cubes will be there that will form a multi-dimensional data. So the multi-dimensional Olap cube will be there for the storage and organization of the data. The Olap data cube definition entails that a cube comprise all the data in a snowflake. So that will be stored in the form of snowflake schema, a star schema. So that there will be the fact table in between, in the middle of that, and there will have some dimension tables. There will have some dimension tables related to that. So the data will be stored in the form of a snowflake schema, a star schema in the cube, right? So the in that the fact table will be there in the middle, that is consisting of data aggregation and reconclining the various dimensions. So that is having the various dimensions data in that. A data warehouse would extract the information from multiple data sources as well as the formats. So that will have the in the form of text file, that can have in the form of Excel sheets, multimedia files. So the extracted data will be cleaned and that it will be transformed and that will be stored and organized in the data warehouse. Now the data will be loaded into the Olap server and then where the information will be recalculated in advance for the further analysis what we can going to do while we are going to do some data mining algorithm we are going to use. So that will be used for that. So that was the simple introduction of about Olap and Olap cube. So measures will be divided, that the cell will be called as a measure and that will be measured, they were derived in the records for as a form of fact table, and the dimension that will be derived in the form of dimension table. So in earlier slide I have shown some fact table will be there will be the some dimension table. So like that will be derived from that particular data cube. So the Olap data will be typically stored in the star schema and snowflake in the relational data warehouse. We can say the special purpose data management system that will call as a data lake, data warehouse, like that. So the Olap cube that will operate through the MDX query. So if we want to analyze that particular cube, so we have to write some MDX query which will be implemented almost instantly. So only in the few syntaxes we can find out the particular analysis. Now, what is Olap cube data model? So Olap cube data model containing its building parts, that is having the cube components in the form of measure, member, level, hierarchy and dimension. So these are the some levels of that particular Olap cube that is related to measure. So this is measure is nothing but that is a real data in the Olap cube. That is measures are stored in on dimension which are called as a measure dimension. What is member? A single data item with dimension within the dimension. So in the dimension table there will be the member. So to access the members is usually implemented through an Olap server, Olap structure of dimensions, hierarchy and other levels. So now level came. The level is nothing but that is a category of aggregation into the common hierarchy. So in hierarchy there will be some level, we can say some of the levels, some of the view will be there. So that will come under the common hierarchy. So we can perceive that levels in the data fields that can be queried. We can write some MDX query and that will be analyzed separately from each other. Then will be the hierarchy that will use for the concept hierarchy. That will be the predefined aggregation of levels in the specified dimension. So the Olap cube hierarchy that allow us to create the summary data. We can use the computer programs for free. We can analyze them and then we can have the different levels of that same structure in the form of hierarchy. And then without delving into the relationship that we are going to that is going to exist in that particular database. Dimensions, that is the main characteristics of the analyzed data elements. So the hierarchy is the elements of dimension that can be organized as a hierarchy, and we can say a set of parent-child relationships. So in hierarchy we can see the what are the parents and child relationships, are what are the tables that is related as a parent child, what are the typically a parent member is going to summarize its children. So the parent elements can further be aggregated as the children of another parent also. So there will be the relationships like that. For example, if in May 2005 parents is second quarters 2005, which in term the child of the year 2005. So the data will be related like this in the hierarchy. So similarly, if we will take the example of city will be the hidden children. City will be the children of region. The product role into the product group are related in individual expenses into into the types of expenditure. So these type of levels, these are the type of hierarchy will be related to concepts. So how we are going to work with that Olap cube? So this is the view of this is the we can see in the right hand side there will be the Olap operations. This is the one Olap cube. On that we are going to drill down that. So there will be the small small portion of that will be drilled down. That we can dice also some of the part, we can have the view of that. And in the roll up we have to we can see we can see the detailed view of that particular data Olap cube. So due to the numerous dimensions of the cube, there can have the numerous dimensions, many dimensions of that. So the query defines the multiple different dimension members that is going to indicate the particular cell. So one particular cell which contains all requisite data for analysis, we are going to do the planning. So beyond that, due to the techniques of building the Olap cube, their structure makes it possible. So we can rotate it, we can see the data from the various perspectives, and we can foresee the further analysis while we are going to use the Olap operations. So there will have the roll up, roll down, drill up, dicing, slicing, like that. Some of the operations we can possibly see for the Olap cubes. Now, what is slicing? Slices is an act of picking a rectangular subset of a cube. So from the one particular cube, this is a cube of the Central Europe, that is having the Central Europe in the one dimension, that is having the ears in one dimension, and there are some related equipment accessories are there. So that will have the slicing is nothing but that is having the one subset of that particular that will have the one particular slice of that particular data cube. So that is having the 2004 data, and that is having the Central Europe, North and South. So on the basis of 2004 year, that has been divided into a subset of cube. So that is creating a new cube with a one fewer dimension. So slice can detach, say the we can say Central Europe's dimension from the rest of the cubes, which will create a separate spreadsheet. So like this we can slice the one cube from that particular 3D cube. So this way we can analyze low level information also, and in the isolated environment. Now dicing. So dicing comes as a dicing operation is nothing but that is producing the subset, the subcube, by the allowing the analyst to pick the specific values of specific multiple dimensions. In the same dimension, we can say here is a data cube. In the same dimension, if we want the particular information, particular specific values of this dimension, so we can do the dicing. So there is have the dicing part of that particular we can say this data cube. So in that we can see here 629 cell, in the cell 629 that is having last is 353. So this part of the data cube we are having as a dicing. That is a dice of that particular data cube. So this operation is similar to the dice slicing, and the dicing provides the same separation functionality, but that is going to allow you to choose more than one dimension, so producing a separate cube. In the slicing we were choosing the one dimension. On the basis of one dimension we were taking it as a slice, and in that dicing we are taking it in a 3D dimension, multiple dimension we can take as a separate cube. Now pivot. So pivot is a similar to the operation to create the pivot tables in Excel, Microsoft Excel. So in that, this function allows us to rotate the data. So here we can rotate the cube to get a different representation, different view of data in between the dimensions. Now the pivot is allowing to the analyst to rotate the cube in space to see the various faces, various we can say views. So pivoting could replace the products with time, as well as to see data across the time for a single product. In that in example, in this figure, we can see this is the pivot of that particular data queue. So that has been that is the years that we can see. The years came in the y-axis, the central loop it is already in x-axis. So like this we can change the dimensions of that. We can see the different representations of data in between the dimensions. So now the drill down comes. So drill down and drill up. So that is just vice versa. So drill down, drill up allows us to users to navigate among the levels of data that is ranging into the most summarized, that is up, and most detailed, that is down. So the drill down allows a user to move from the high level data. If the annual sales is in the high level, that is going to a lower level. So that will do as a drill down. So that will have the concise summarized view of data in a drill down. So here we use the concept of hierarchy that applies to every single dimension. So that will comes in a hierarchy that lower level dimension will come first, then next, like this the hierarchy will come down. So this depends on how you are going to store our data in the data warehouse and model the actual queue. So this is the representation of drill down, drill up information operation. So that is having the we can say here we can see the drill down of this particular queue. Now the analyst moves from the summary category that is having the outdoor protective equipment in this, right? And that has been dropped down. Actually, that has been removed. That has been hidden. So to hide that hide that particular dimension, we are using the drill down. So drill up means more detailed information. Information of the dimensions we are going to take. So like this, we can see for the individual products. So it can be done by moving down in the concept hierarchy and adding a new dimension for the drill up. Now roll up. So roll up and roll up is the opposite of the drill down, and because it is basically lift the data into the hierarchy level. So both operations make the data more or less detailed and remove the dimension for the analysis. So a roll up in that is actually removing, that is hiding the data. The drill that is having the hiding the data, but that is removing the dimension from that actual queue. So a roll up involves the summarizing the data along a dimension. The summarization rule might be an aggregation function, that is using the aggregation function. So general aggregation function may be costly if they cannot be determined as for the cells of the queue. So that these of the operation can be costly if we are going to aggregate, if we are going to do the roll up for the particular data. So there must be some there must be counted from the base data, either that is computing online, that will be slow, and then it is going to pre-computing them for the possible rollouts. So that will need the larger space to do that. So aggregation functions for the roll up is very, very costly. So now we will go into the example of one example we will take. So consider the following cube that is illustrating the temperatures of several days, certain days recorded weekly. So that is having the temperature data, that is having the week 1, week 2, and there will have some temperatures. There is a 13 temperatures from 64 to 85, that is having some cubes on some figures on numeric values on that. So consider that we want to see a level. So what are the levels are there? There can be hot in weather, there can be low weather, there can be cool weather. So like this we can have the temperature from that specific table, a specific cube. So we have to group the columns. So we have to group some of the columns, and then we have to add up the value according to the concept hierarchy. Now this operation is called as a roll up. So that was the roll up operation. In that we have to make a group of columns and then add up a new value. So by doing this we contain the following cube. So the cube will become as a, we have aggregated it as a form of cool, mild and hot. So the table came as a, the cool is 2, mild is 1, hot is 1. Week 2, in week 2, the temperature that is cool, mild and hot. So the particular cube will come out that. So the roll-up operation that is going to group the information by levers by using the temperature. So on the basis of temperature that has been cubed, that has been aggregated, and the following diagrams relate that is going to illustrate the same how the roll-up works. So roll-up will be in the form of that is a table on the basis of that. So that is having the item types, that is having the quarter, that is having the city. So over the city, how the roll-up on location from city will be on the basis of country. So from the country, that roll-up has been used here. So that roll-up it is taking the USA and Canada instead of Vancouver, Toronto, New York and Chicago. So that is example that we can relate with that example. Here we have aggregated, here we have used the broader view of that particular temperature. So temperature can be categorized into the form of hot, cool and mild. So the cities also can have the state, so the district. So the state will be the Canada and USA. So like this roll-up will come. So roll-up operation looks like this. Now drill down. So drill down also called as a roll down. So figure shows a drill down operation performed on the dimension time by stepping down the particular concept hierarchy, which is defined as day, month and quarter, year. So now the drill down over this city example will come under. First we will check this example, that is nothing but the same values that is has been divided into the cool, mild and hot values. So that if we are going to drill down, so there will have the if the month, the time that is looking into the quarters, that can have the values that can have divided into the form of different months. So months name as there January, February to December. That has been earlier it has been saved into the form of quarter 1, quarter 2, quarter 3. So in quarter 1, January, February, March will be there. In quarter 2, for April, May, June will be there. Like this, that has been divided. So that will be the drill down of that particular cities. Now drill down adds more detail to the given information, given data. So like this, we have seen the more detailed example from that, because it has been stored in the form of Q1, Q2, that will be the quarter, and then it has been divided into the form of month's name. So because of drill down adds more detail to the given data, it can also be performed by adding a new dimension to the cube. So the particular drill down can also have the ability to add the particular new dimension, new cube on that, new dimension on that. For example, a drill down on the central cubes of the figure can occur by the introducing the additional dimension such as customer group. So in the form of that particular customer groups, we can also have the view of drill down. Slicing. Now slice is a subset of a cube that is corresponding a single value for one or more elements of a dimension. For example, a slice operation is executed when the customer wants to select the one dimension of a 3D dimension data cube that has been that can be resulted into 2D data site. So the slice operation have to perform the operation onto the selection on one dimension, so that on the given cube, so then resulting is a subcube. So that data cube, and in the size of in the form of slice, that is having the for time q1. If we will take the for time q1, so that will have the for q1, that cell will have the that particular slice on that. That will be the 2D dimension representation of the from the original cube. So for example, if we will make the selection temperature is equal to cool, for the other example we have seen for that table, so we will take the that type of cube that is related to the data cool. So related cool temperature, the data slice will be seen. So here the slice functioning for the dimension time, and that using the criteria time Q1. And on the basis of Q1, all the data slice has been represented here. So it will form a new subcube by selecting one or more dimensions. So that is a purpose of slicing. Now the dice operations comes. So the dice operation describes a subcube by the operating a selection on the two or more dimension. So that is selecting one or more dimension for to dice that particular data that will have the broad view of that particular data cube. For example, implement the selection time is equal to day 3 or time is equal to day 4, and that is the aggregation temperature is equal to cool or temperature is equal to hot. Only one we can take from here. To the original cubes we get the following subcube. So that is still the 2-dimension data. So in that from that particular data cube we have got this from that particular dicing, for the dicing. So that dicing will be there for this. This was the actual data cube for our city example. In that the slide that will be diced for location Toronto. The location will be for Toronto. The time will be, and the time will be Q1, and item will be mobile. If 3 will be there, the dice will come as like this. So there will have the mobile, there will be have the time Q1. So if we are taking both of that, Toronto and that, so that the dice will come as a 3D cube. If we will take the one only, so that will come in the form of 2D dimension. So the dice operation on the cube based on the following selection criteria involves 3 of the dimension. So what we have seen in the location, that there will be the location Toronto or Vancouver. So that will show the both of the 2 dimensions. The time will be for Q1 and Q2, Q1 or Q2. So the Q1 and Q2 both have been seen. So item will be mobile or modern. So that has been seen. So modern. So that has been shown in that particular dicing of that particular data cube. So that was all about the multi-dimensional data cube operations. So what are the Olap cube operations we can do? So we have seen with the example. So 2 of the example I have shown as one example was the particular related to table, that was for the easy understanding, and other was the pictorial representation of based on the city. So on the basis of that we have choose the some of the criteria, some of the we can say syntaxes were there. On the basis of that the dicing, slicing, the dicing will come out, the slicing have come out, and the roll down and roll up drill up has been taken out. So that was all about the problems on multidimensional data cube operations. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.